Yes, hi everyone, and thanks for joining. We're going to start after the intro that Nera did. We're going to start with speaking about the gaps between dev, DevOps, and Sec teams as an intro for what we are about to cover here, which is the integration between JFrog and Vdoo. And then a reminder about the JFrog platform for those of you who are not familiar with it. And we will also talk about X-Ray, which is JFrog's main security product as part of the platform. And then to the most interesting thing is why JFrog and Vdoo, what's the added value, what's the big story together. We're going to get a deep dive into the advanced features of Vdoo that got us really excited in making this move in acquiring Vdoo. We'll talk a little bit about the future, about what's coming up next with this great collaboration, and then we'll turn to questions and answers. So as an intro, I'd like to speak about what we see as JFrog with the majority of our customers between those three worlds of dev, sec, and ops. The DevOps movement started a big shift, a big cultural shift for automating everything, so doing everything as code. And while this, on the vision of it, it was supposed to bring people closer together, it actually created some gaps that are around trust. So what we're seeing ops not fully trusting developers, especially in large organizations where production is managed by special teams. So they will not always trust developers to make production changes and consume resources in production because everything is very easy now. You can make those changes by changing your Kubernetes config files, and we're actually seeing this movement sometimes towards a zero config world where developers just ship their software and production takes care of everything. And also some in the real world things like Fargate and serverless, they kind of promote this notion of keeping those worlds separate. And another trust issue we're seeing, which is more related to this webinar, is around security. So the sec guys, they will trust DevOps to some degree with the shift left, so they will. It's easier and it's desirable to fix things when they happen on the left because you catch them very early on. But they will always come with their tools and do another check once things are moving towards production. And the same thing between the trust between sec and ops. And if you have configuration that configuration in production and applications running that impact security, then the sec guys will always want to come with their tools and do a double verify and do a double check. I compare it a little bit to airport security, where because of the risk that is involved in getting on an airplane, you will be advised to check your bags and to take liquids out and so on, but at the end of the day, there's always going to be a scan. You're not going to be waived from this final scan to make sure that you're fully kosher to board the plane. So it's the same with production and with sex. They still want to have their tools and to have 100% as much as it's possible verification for what goes in production. And developers, they just want to develop and do the cool stuff. And the common ground between all those three bodies is really the binaries. This is the binaries that end up in runtime. This is what developers develop. This is what security scan. This is the surface that they want to scan at the end of the day because that is what's running. And of course, this is what the ops are delivering to production. So I'll pause here and do a quick intro to the JFrog platform. So just as a reminder, so it's an end-to-end release, software release management platform built mostly around the fact that binaries are the ones that are making your software release. And we have, once you've coded something and you built it, you have Artifactory to store your artifacts and third-party dependencies. We have X-ray that is doing scanning and security and compliance verification for your software release, which is the main thing we will talk about in this webinar. We have JFrog Pipelines, which is our own CI/CD solution that's tightly integrated into the platform. Distribution, JFrog distribution, is what allows you to take a software release and push it to edge locations closer to your runtime. And now we also have a private distribution network that you can create similar to a CDN just for software releases. And finally, we have mission control that allows you to oversee the whole process, especially if you're working across different data centers globally. So that's the JFrog platform. And to reiterate about the points of binaries, the binaries that you're creating and that are flowing through the software release pipeline are the same binaries. The CI binaries that you're creating are going to be the same ones that you're eventually releasing. Of course, just a small portion of them are going to be worthy of a release. It's going to be the same binaries that you're distributing. And finally, it's going to be the ones that you're putting into runtime and then operating them and monitoring them in runtime. So to speak about JFrog X-Ray, let's focus on the security now. What JFrog X-Ray does, it allows this protection of the software release pipeline, actually even before you have binaries, even when you start with the first lines of code where you need dependencies in your application, then X-Ray is going to do the scanning in the IDE and very much soon using also in your Git repository. And then when you build and package your software release, we're going to do the software composition analysis. We have a unique SBOM for your build that actually taps into the build process and captures the real information about dependencies and the production artifacts of your build. Everything comes with the actionable policies that allow you to prohibit downloads, for instance, for unsafe dependencies and so on. Finally, when you push your artifacts and you deploy them to production, or you distribute them to a runtime that is outside your development organization, we have a JFrog distribution that is integrated with X-Ray, and we have an SBOM that defines the full application with all the subcomponents of it, and X-Ray will scan it prior to distribution. And finally, when you operate, we're going to allow you to monitor and make sure that the things that left the organization that went to the runtime, but still you have a view for them, we will be able to show you the impact of new vulnerabilities that appear in the world. And everything, of course, comes with remediation advices to fix things easily. And the way that we're doing this monitoring of something that is already deployed is done through a very unique capability of X-Ray called recursive scanning. So the way that we do it is we index components only once, we scan them and we keep them in the database. This scanning is recursive. So it's, think about a Russian doll model where we take apart a software release and we go all the way to the deepest known component. So in this example, we can see a Debian package installed on a Docker layer in a Docker container that was created by a certain build. So we keep this hierarchy. So, and this is quite a challenging engineering effort to keep this graph about all the parts of a software release and how it's being reused across different releases. And once we build the component graph, we can match vulnerabilities that either new one or ones that through monitoring appear in the new world. We match them against the graph and we can show you the impact analysis and the containment of everything. So that allows us to, it's like when you do a recall for a vehicle, because some part is faulty, we can show you this impact path, we can show you the faulty artifact, the faulty release that kind of makes your whole release vulnerable, and link it to what you already distributed or deployed. So that's a unique value proposition of JFrog Xor. So the big question is why JFrog and Vdoo together? Why did we make this move of acquiring Vdoo? When we first met Vdoo, just apart from the fact that both companies are very much focused around binaries, and Nati and Asaf from Vdoo will speak about that, we got excited by 5 main value propositions that Vdoo comes with that we have not seen anywhere in the industry so far. So the first one is accelerated mitigation. It boils down to very unique technologies and techniques that are used by the Vdoo team to scan artifacts and really reduce the noise that is associated with vulnerabilities, looking at vulnerabilities in context, and really making sure that what we are presenting as vulnerabilities plus the mitigation advice is just the stuff that actually matters and not noise that is just a toil for users. The other thing is fully automated zero-day detection. So vulnerabilities that exist but are not reported anywhere. So that's another big advantage. Universal device protection. So the Vdoo product it have very strong origin in IoT devices, and they cover a gamut which is pretty wide of devices. So that opens JFrog to a new world of IoT and devices, which relates, but not only, to C and C++ application scanning. So we have Conan as a technology owned by JFrog, and if you're building everything with Conan and you have access to the Conan build information, then you kind of know your software bill of materials when it comes to C and C++. But what Vdoo brings is even stronger, because they can, using unique technology, identify the C and C++ components even without this information, and also variations of those. So that's another very exciting facility. And finally, runtime protection, the ability to protect and monitor your runtime. And here I'll let the Vdoo team take it away and speak about it.
Well, thank you so much, and I'll take the opportunity to express again our excitement for joining the JFrog family. And this is actually our first joint webinar as one family, and of course not the last one. So thanks for that. And I'll start by saying that everything in Vdoo, now JFrog Security, is around the Vdoo people, because a major part in our approach is how to automate the attacker mind and the researcher mind in a way that can later on focus the developer on the right things, as you all mentioned. And the Vdoo teams bring indeed a very unique background and experience in the software vulnerability research space, and therefore represent nicely the attacker point of view, the attacker perspective. And we also come with a unique knowledge in exploit mitigation. Exploit mitigation is a generic way to deal with exploitation of software vulnerability without chasing after patches, which is, of course, a very important approach. And more specifically, we are coming from endpoint security. When I say endpoint, I mean any kind of endpoint, whether PC, server, mobile phone, embedded device, or any other kind. And actually, when we started initially at the end of 2017, the main focus of Vdoo was embedded security, which was considered and still considered to be the most complicated software security space because of its uniqueness, because of the unique knowledge that you need to have in order to deal with it properly. And then we gradually extend our capabilities to support far beyond just embedded systems when we found out that the approach of binary security is applicable on actually any kind of binary. We are now 90 employees. Actually, we are 800, part of JFrog, and working with the top tier companies out there in many industries, focusing on Fortune 500 and now going to extend it dramatically. Important to say that Vdoo is also an official, or maybe the first authorized CNA in Israel. It means that we can register CVEs, vulnerabilities ourselves and on behalf of our customers, which is, of course, a big thing in order to enhance the data set of X-ray and all in all the knowledge that we have in the company to the benefit of the customers. Now I will very quickly touch the Vdoo approach, which was mentioned partially by Yoav, and of course is very much aligned with the JFrog approach, and therefore the reason for the great connection between the technologies, the product, and the companies. So first of all, it's all about binaries. Looking at the binary is the only way to really understand what matters, because that's what is being released, that is what is being used in the field. That is what's being attacked, not the source code. You're not releasing, I mean, some cases you have source code on a device or on a server, but generally speaking, you release your software in a binary form. Second is that the source code does not cover everything. There is a very, very long way between the source and the production. And many times you don't even have all of the pieces of your software product in a source code form. You get third-party binaries, for example, drivers, for example, other off-the-shelf solutions that you need to deal with. The other thing is that this is the only way to really perform a real contextual analysis, because again, it mimics whatever software product you have in field, and this contextual analysis can reduce dramatically false positive rate and therefore reduce dramatically the overhead of going through huge amount of entries by the typical software security tools. And it also covers blind spots that are not covered by, that you can actually not deal with when you are focusing on the source code only. Things like configurations, things like how do you encrypt your keys or protect your credentials, or what specific hardware architecture you use. These are things that cannot easily be identified through source code and are much easier to identify through the binary that consists all of this information. So this is first. Binary goes first. The second thing is that also derived from the binary approach is that it helps on focusing on what matters the most, because again, when you have hundreds or thousands of potential issues, potential CVEs, potential 0 days, it doesn't really mean nothing yet, because you need to take this result and analyze it again in the full context of your full product. For example, if you use kernel 4.4 or God forbid 2.6, and you have probably more than 600 CVEs, most of the tools out there will tell you, oh, you need to replace those. You need to upgrade your system. You need to upgrade your solution, which will take a year, give or take. But no one will tell you, listen, this is not really, half of them are not really exploitable because of your specific ARM architecture, or because you use ASLR, or randomization in the memory, or because your specific kernel configuration won't allow such exploitation. These are the things that can be analyzed through binary. These are the things that are being analyzed by our solution. This also allows, of course, to focus on the right things and also to prove why they are the right thing to deal with. And this also goes back to the ongoing tension between the developer, the engineer, and the security team of focusing on the right things rather than just creating more and more work. When you show the proof, when you show the digital evidence of why something is really exploitable, that's something that will convince the developer that he truly needs to deal with that. And when you add on top of that the exact instructions of how to mitigate it very quickly, as you have mentioned, this is of course another huge value. The third point is that the binary is the only way, focusing on binary is the only way to mimic what the attackers goes after. And this is also how we work. I mean, we have an ongoing endless research, and we will keep doing it, and we will enhance it and extend it, because the only way to deal with the new emerging threats is by knowing about them before the attacker does. So it's about finding 0 days and reporting to the community and to companies. It's about finding a way to mitigate them. It's about going through each and every new reported CVE and understand its nature, understand its real implication, understand the prerequisites for its exploitation, and write new tools to see if this is really exploitable on a specific given piece of software. We are doing it around the clock. We have one of the best teams globally. And this is going to enhance dramatically the capabilities, the data set that is being used today or provided today through X-ray, and we are working to do it as soon as possible. The last point is comprehensiveness, and I would say it's one of the most important points. There are so many tools out there, so many application security testing tools, static analyzers, fuzzers, many niche solutions. The only way to really deal with product security is to see it all in the same place and see the contextual relationship between things. I I mean, between configuration issue and a 0-day, between CVE and hardware architecture, all in one place that serve both the security champions and the developers with the proof, with the guidance, with automated compliance testing. And that's what we came with, all in one place, dealing with third-party issues, dealing with first-party issues, dealing with your own proprietary code, and dealing with whatever in between, what we call productization security issues, things related to configurations, to general security architecture, to standards out there. All of these things are being tested automatically in our platform. This is the approach. So I hope it was helpful, and now I'll hand over to Asaf to get into the technical details, and of course, we'd love to answer any questions at the end. Thank you.
Okay, thank you, Nati. So to take Nati's point on contextual analysis, we'll start with accelerated mitigation, which is one of Vdoo's main values, and one of our core capabilities is, again, looking into how to accelerate the mitigation of dealing with findings that were found during the scan. And the first and foremost is prioritizing vulnerabilities that could be CVEs, but also configuration security that Vdoo checks for in 0 days with applicability scanners. An applicability scanner is a technology that Vdoo developed where we check for the conditions that needs to exist for the vulnerabilities to be applicable for a specific artifact or binary. Many vulnerabilities have prerequisites that needs to be fulfilled, and the only way to test for the existence of these is to look at what is going to be deployed, as Nati said. The existence of these prerequisites is of multi-levels. It can be, of course, in the code itself, whether a specific function is being used and whether it is being used with a specific argument, and also whether it's being used where untrusted user input is flowing into the insecure code. Those are the kind of tests that Vdoo performs on the actual code, whether binary or if it's intermediate or interpreted languages that are found in the artifact like Python and Node.js and Lua, but also very crucially on compiled binary code. Now, with the applicability scanners, we also test for configuration, whether a specific program that is vulnerable has been configured so this vulnerability is relevant. I'll give just a very recent example. The DNS spook vulnerabilities in the very popular DNS mask DNS server. These were only relevant if you compile the binary, the DNS mask binary with the DNSSEC support, the support for the DNSSEC protocol, and if the configuration indeed enabled it. And Vdoo analyzes the configuration file. It also can analyze the command line, the flags that are given to DNS mask, because it can analyze entire images, entire firmware, and when it does, it has the context of how they are executed. So we also do configuration analysis as part of whether the vulnerability, determining whether the vulnerabilities are indeed applicable. So cross referencing these two gives you a much more clear view and prioritizing whether that vulnerability should really be addressed or not. Moving to another very important part of accelerating mitigation is detecting patches. Many times with embedded software in particular, and the kernel specifically, but also in many higher level open source applications, developers are applying patches, backwardating patches, and not necessarily updating the versions accordingly. Many products are just scanning based on the version. With Vdoo, we detect the patches because we actually look at the code and try to see whether the patch has been introduced or not. And if it has, we don't alert on that. We don't create a lot of alert fatigue for issues that really don't exist. That's another part of accelerating mitigation. Nati touched upon this very briefly, but it deserves more context. It's threat intelligence. Vdoo has an extensive security research team that have discovered hundreds of 0 days using our technology and manual research. And it continuously innovates in this area where it scans and actively searches for vulnerabilities in open source components, but also in closed source third-party components. And many of our customers have been alerted in advance on upcoming security issues that Vdoo has discovered using its technology and staff, but also monitoring many different sources, public and private, to determine whether new vulnerabilities are published or becoming or in the process of being published, understanding what they are, performing comprehensive analysis on their meaning, on their prerequisites, and then going back to applicability scanners, developing very rapidly applicability scanners to test whether these vulnerabilities are relevant for the artifacts and binaries of our customers. Threat intelligence is a significant part of Vdoo's core value because it represents that attacker's mindset. The fact that many vulnerabilities, open source vulnerabilities in particular, are not exploitable unless they are being used in a specific way. And attackers in the end have to have those conditions met unless, if not, the vulnerability is not exploitable. So having that attacker mindset, writing and elaborating on vulnerabilities is a huge benefit. Moving on to mitigation guidance, when there is a vulnerability and it's actually applicable, we need to be able to mitigate it fast. And Vdoo provides guidance on how to do it with knowledge-based articles that expand and describe the topics in detail, but also with very particular copy-paste and developer-friendly instructions on how to solve and mitigate the issues. It can be on how to remediate critical CVEs that needs to be fixed, but also how to fix a code issue that Vdoo can scan, and also configuration issues, real instructions that require you to really read and then implement very quickly. And last is a huge part of mitigating issues is to be able to comply with standards. And Vdoo's findings are mapped to dozens of standards, which be from industrial standards, medical standards, automotive standards, where the findings are mapped to specific requirements that these standards and regulations ask. And this helps to very quickly understand whether you are in compliance with the requirements or not, and show and prove that you are. This is done automatically, and the findings really show that very clearly. For example, Vdoo has customers that are in the industrial domain. ISA IC 6243 is very important, and for that, Vdoo has mapped specific requirements for the product part of that standard, and it really checks for specific issues in your binary. So that's for accelerated mitigation. The next part is very significant. It's really the ability to scan also proprietary code, but because Vdoo works on binary code, it can also scan third-party code that you don't have access to. 0 days really finds unknown vulnerabilities in the code, and it can also search for malicious code. With supply chain being a huge issue, the Vdoo technology can detect malicious code that tries to perform malicious actions, whether on the developer's station, but also to find itself into deployment. So how does that work? We support both compiled binaries and source code in multiple languages, and we use different techniques to do that. Those techniques have led to the discovery of, as I said, over 400 critical 0 days. And the first and foremost, we use next generation static analysis to be able to detect vulnerabilities with a very low rate of alert fatigue. So we look into doing the same thing that we did with applicability. We look into finding vulnerabilities within their context and not just looking at the code. We're trying to detect whether what are the sources where user input, untrusted user input, will come into the artifact, where it's, again, an image or just an application or even firmware, and try to understand if these sources end up in insecure code. Insecure code could be in C, C++, an unsafe memory copy that isn't filtered and isn't checked for size, but it can also be a command injection where you use popen in Python. That's part of the technology where you really try to look at where the software receives its input form and whether they reach into dangerous areas without filtering. This is done through data flow analysis, but also we use two rather unique technologies that are being used automatically, and that's fuzzing and symbolic execution. With fuzzing, where we detect specific functions that perform parsing and are more susceptible to the kind of issues that fuzzing can find, usually on C and C++. And we emulate those specifically as single functions and really try to generate inputs very quickly that might cause them to act differently than the developer intended and even cause a memory corruption issue. We detect those fuzzing functions, by understanding whether they actually also receive user input. So we only fuzz what might be accessible to the attacker from the network or from files. So that's a huge part. And we do the fuzzing automatically, where the harness is being built, the function wrapping and how it's being called. It's being deduced automatically through binary analysis, which really saves time and effort and doesn't require any work from the developer that is initiating the scan. With symbolic execution, it's a technique where we analyze the behavior of a program by considering all the possible values of the variables that we are interested in, and we are not using concrete ones like we do with perhaps with fuzzing. The program is emulated, and we build logical expressions that eventually will give us an answer on which conditions these variables will be able to get us into a specific condition in the program. So whether there exists such an input that will lead me from user input to executing a command. So that's a very advanced technique that we use in some of our scanners. Last, I've mentioned malicious code. So backdoors, that's a term we are all familiar with, and we've seen more and more of these happening, whether for open source packages in like Python or Java or Node.js, but also in closed source in C, C++, and C#, for example, like the case of SolarWinds. So Vdoo can analyze these and try to detect malicious actions. Some examples of what we're doing: we try to detect dropper activity, where you have a package that simply connects to URL, a server, and downloads code and simply executes it or evaluates it using the eval function. If you have packages that access sensitive information like password or shell history of the developer's workstation, or even credit cards that are saved in the browser, these are the kind of things that we look for in the code to see whether you are being attacked through your supply chain. Another thing that we are seeing and monitoring is whether a specific program is trying to mine blockchain. These are all cases that we've seen through our active monitoring of open source packages, and are now detecting to see that they are not entering into your artifact. Backdoors, lastly, that's a rather unknown term, really means vulnerabilities that were not introduced by error, but by intent. And with the zero-day vulnerability detection, we can actually, because we work on binary, we can actually look into those as well if they were introduced as part of the build chain. We can detect these vulnerabilities because we really look at the final outcome and try to understand whether a specific vulnerability has been introduced in a way that changes the flow, that is very in places that haven't been changed. These are the kind of things that we do to try and detect backdoors. Moving on to our embedded side of things. Again, Vdoo comes from deep roots in the embedded software, where we support multiple operating systems that have been built specifically for embedded devices and real-time operating systems. So you can see here, first and foremost, VxWorks, but also Green Hill Integrity, FreeRTOS in all of its form, embedded Linux, by far the most popular operating system today for embedded devices. Specifically, Vdoo has been working with Yocto to scan for the Yocto organization. We are working them as partners to scan the base image Hockey that Yocto is building, and we are really supplying them with configuration analysis and also SBOM and STA analysis because we work specifically with them. And naturally, that means that any image that is built with Yocto has been can be scanned by Vdoo. Also, of course, Android, very important operating system that we've developed specific configuration, security, and tests and scanners as it's being heavily used in the automotive domain. As for architectures, these are different kind of architectures. The most common one, ARM, both Cortex-M, Cortex-A, and others, 32-bit and 64-bit MIPS, and the 2 platforms. Last and very important with devices, as part of, as Vdoo expanded, more and more of our customers were also interested in the controller app that controls the device. These are mobile apps that run on the user's smartphone, so Vdoo can analyze Android APKs with the new format AAB for all the things that we've mentioned, 0 days software composition analysis and how it's built, and it also maps it to the OWASP standards, and also iPhone IPAs. That's a part of how we look at devices and also look at their ecosystem. Yeah. With C and C++ application scanning, you have mentioned Conan. We were big fans of Conan, but we had to also support developers that were not using Conan. And you can see that also in the RTOS systems I mentioned, but also in cloud and web-facing apps where C and C++ is being compiled. And Vdoo has developed a very unique technology to detect libraries and to be able to determine their versions, even if they're being compiled in a custom manner. And we do that through machine learning, where we use our huge database of compiled binaries, and we perform binary similarity between the binaries that are being scanned by the user and to our own data set. And then we detect similarities in the code and determine version. We also look into the compiled binary and try to find configuration issues like compilation facts, secrets that are in the binary, and really try to understand whether it's being built properly, doesn't contain debug symbols to be able to sign it off for production. These are the kind of issues that are usually being exploited by attackers, even just for the sake when they research these binaries and try to find vulnerabilities. The existence of debug symbols is a huge help, and that's part of the things that Vdoo checks. It can only be checked on the binary. I mentioned earlier, zero-day detection for C and C++. Obviously, memory corruption is a huge issue there, as we are seeing as being exploited. And Vdoo's comprehensive binary analysis of fuzzing can really detect those kind of issues quickly and as in a similar way to as the attacker would have done. Runtime protection. Vdoo's embedded runtime agent, or ERA, is an agent built to protect embedded devices, but it's also able to run on any Linux and even containers. It was built for embedded devices, where we built and generated automatically, and we tailor it for a specific image. Each ERA agent is different. It's being built and compiled automatically by the system, and it has its policy defined for each artifact automatically. The core capability is smart whitelisting, where we only allow the execution and the loading of trusted known code and not anything else. Nothing that was not in the original image and was vetted will not be able to execute. So we're big fans of whitelisting and security instead of blacklisting, and specifically for embedded devices, but also for containers and read-only, and where you have read-only file systems, and where you have a very specific image that you know of that is going to run. The whitelisting works excellent, and we do it in a very simple way that doesn't require complex configurations like you have to do with other off-the-shelf mechanisms like SE-Linux, for example, or ARMOR. Another very unique layer is exploit prevention and mitigation, where we detect and prevent attempts to exploit memory corruption and input sanitization vulnerabilities, and where we are able to detect them as they happen and then prevent them, stop them, and alert, which leads me to the last part of continuous monitoring. We do continuously monitors through ERA, and this can be sent to SOAP or PSER, where alerts will be received. Yeah, Nativ?
Actually, it's me. Thanks.
Yeah, you are. Sorry.
No worries. So basically, for runtime, if I hear you correctly, we're applying zero trust also in the way that we do runtime protection, which is great. So to summarize, there is a big story for us here, why we're better together. So the left side is things that JFrog already provides. It's the native integration with Artifactory. It's the scanning for vulnerability and doing the impact analysis on them. It's the universality. It's the universal package support that Vdoo actually brings also, but not just for packages, but also for devices. Fully automated security and license compliance, and finally, the ability to not just scan binaries, but also scanning bombs, S-bombs, which are actually in the JFrog platform. They are also binaries because we treat them also as immutable binaries that we want to keep in Artifactory. And the right side, this is the addition, the natural addition of what Vdoo brings to the table, which we just went through. The accelerated mitigation, the minimal noise, the zero-day detection, the universal device protection, the C and C++ application scanning, and the runtime protection. And everything is concentrated around doing that on the real thing, on the real attack vector, which is binaries. To talk a little bit about what's coming up next, except for the part that we have great synergy and vision together that is, like I said, laser focused on binaries as the only way to guarantee application security. If you remember the initial opening with the gaps between the dev, the sec, and the ops, this is bridging the gaps and bringing a common ground that everyone can agree upon and use as a common base to achieve security that is acceptable by everyone. So first thing that we will do, and we already started working on that in this quarter, is to enhance X-ray with the Vdoo vulnerability data. We're actually doing a little bit more. We're hoping to finish by Q3, even applying some of the lightweight vulnerability scanners that Vdoo has in order to enrich this data, not just with existing data, but also to allow those scanners to automatically identify security issues which are not coming from public databases. Of course, everything includes remediation. One of the things that got us really excited when meeting Vdoo is that when we did the due diligence, it almost felt like there's a security expert standing behind your shoulder and advising you on the right way to fix things, which developers, even our developers, they loved it. In 2022, we're going to proceed with this effort, and slowly we're going to introduce into the JFrog platform. So everything is targeted around the JFrog platform, around the JFrog security and the extra solution. We're going to enhance it, and we're going to bring all the great values of the Vdoo product into the JFrog platform. That's going to be the main effort for us coming in 2022. This is it. I think it's a good time to switch to questions from the audience, and I see that there's plenty of questions. Maybe Asaf and Nati, maybe we should start. There is a question about 0 days, and do you want to read the question and take it?
So I can read it if you want. What kind of 0-day vulnerabilities can be found automatically? Can you please provide some examples of 0-day vulnerabilities your product has found?
Yeah, sure. So many different kinds. We use CWEs, common weakness enumeration, to mention them, and I will not go over all of them, but just for major families are, of course, the memory corruption. We're talking buffer overflow, load stack and heap, integer overflow, stuff like that. And also the more advanced one, like use after free. These are the kinds of issues that we detect in the memory corruption family. And input sanitization issues, command injection, path reversal, the usual suspect. This is also done on binary, but also on the intermediate interpreted languages that we support, and also Java. And also different kinds of logic vulnerabilities where we try to detect whether there are authentication bypasses or unsafe crypto. These are with cipher switch. These are the kind of issues that we detect with 0-day vulnerabilities. And for examples, there are many. You can go to see on the Vdoo's blog. We found vulnerabilities automatically in embedded components like the Wi-Fi cards. It's the software of Wi-Fi cards provided by Realtek and Qualcomm, used in millions of devices, but also in application layer, things like Nano HDPD, Mini UPnPD, Lead Modbus, an open source product used in the industrial domain, and many different ones where we found all from information leak to memory corruption and input sanitization. And of course, we also found in embedded devices themselves, for example, in the access cameras. So all of these are the kinds of things that we can detect using this technology. Yeah.
So another thing that got us really excited around this area of 0 days is that even in a recent example, the thing is that when you find a 0-day vulnerability, you want to automate that, and you want to. There's initial research phase where you find out how you can identify such a vulnerability, but at the end of the day, you want a tool that can fully automate that. And one of the recent examples I started to speak about is remote code execution in Python libraries that we saw, and that is also available in the Vdoo blog. We saw other vendors that initially found it through some, even you can call it social engineering, by digging into web resources and trying to create a linkage between the original committer that puts this vulnerability in, that allows him to do crypto mining. And what Vdoo did is once they were exposed to that, they were able to write a scanner that automatically finds it and uncovers these vulnerabilities in a fully automatic automatic way without requiring any manual research. So that's something that you can put in the product and deliver to your customers and have this protection for them in a fully automated way, which is, for me, it's great. I will maybe take the next question around there are plenty, okay. So I will take the next question around JFrog. Will JFrog X-Ray be deprecated in the future and replaced with the Vdoo equivalent SCA tool? So I kind of touched on it in the summary. No, the idea is to bring everything into the platform and really extend what is X-Ray today to encompass all the capabilities that Vdoo brings to the table.
Okay, maybe another question. Will the new Vdoo technologies be available as on-prem, cloud, multi-cloud, and hybrid deployment like the JFrog platform?
Yes, so I can take that as well. Everything we're doing is hybrid, and the same applies to Vdoo and to the features that Vdoo brings to the table. We're going to support a hybrid model as always, and Vdoo already has both hybrid and in the cloud offering, which also made it attractive to JFrog to pursue.
Okay, another question around that from Peter. Vdoo will become part of X-Ray, not a separate add-on. So I guess you confirmed that.
Mm-hmm.
Okay. So we have a lot of questions.
Yeah, so there's one on plans to implement the standards SPDX format for SBOMs by Eric. And yeah, we definitely have plans. Vdoo from our latest version already supports that, and that will also come into X-Ray as this integration matures and takes place. Yeah.
Yeah, and that also is linked to what to the technology that JFrog has around build info and release bundles, which are partly, and the stuff is being modest, is actually sitting in the body that is creating the SPDX SBOM standard. There's a lot of overlap, but there's also a lot of production proven knowledge and information that is captured in the SBOM that is part of the JFrog platform. So there's definitely going to be a mutual knowledge transfer and integration between the standards. A question for Kami: can Vdoo be used as a POC now, or we would have to wait until it's integrated with X-Ray? So we're going to, so the way that you can consume Vdoo now is we're going to inject the Vdoo functionality, and we're very bullish about it in the way that we want to deliver it. But you will get it slowly by slowly. You will get this added functionality added to the JFrog platform to X-Ray. So that's the way to consume it. There is no separate POC, but of course, if there are specific questions or specific things that any of you would like to learn, we are here to take it further and answer additional questions.
And there's another question here by Sadhir specifically about the Vdoo support on FDA public vulnerability in oncology medical industry. So I'll answer more broadly. The answer is yes. The 40+ standards that are being supported and mapped into the requirements and tests and scanners in our solution includes the FDA market pre-submissions and post-submissions, and we ongoingly add more and more requirement in many industries, like Asaf mentioned, the IC 62443. There's, of course, the new WP 29 for the automotive industry. The more standards we see around, the more we add them. Clearly, we will not add everything, but the ones that are becoming more notable and globally, whether in Europe, US, and Japan. Another question coming from Jeremy about what Vdoo is adding on top of X-Ray, on top of the software composition analysis. Is it SAST, DAST, YAST, and RASP? So the answer generally is yes, 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 and yes. And more broadly, eventually when we complete the integration, and this is an endless game, we'll keep adding more and more capabilities. We want this to be the ultimate product security platform on top of, as part of X-Ray, that will obviate the need for any other solution. And this can be done today as part of Vdoo, but again, we are working extensively on this integration, so it can be part of X-Ray. On the RASP side, sorry, it's not exactly the agent, but in terms of the ultimate, again, approach and the way to deal with the runtime software, the solution that we are going to introduce should deal with that as well.
Okay. I see we have a lot of questions, but we're also unfortunately running out of time. So we will make sure to follow up with you via email and answer all of your questions. So Yoav, Nati, Asaf, any closing words on your side?
We're very excited about the future. We are working very hard on delivering this functionality to you as soon as we can. And yeah, it looks like a very bright future with great functionality coming into the platform around security.
Couldn't agree more. Yeah. Looking forward.
Sorry, Asaf, go ahead.
Yeah, I said we couldn't agree more with Yoav. We are really looking forward to bringing this technology to everybody here and all the JFrog customers, and bring also new customers, because Vdoo is really about making developers' life easier when it comes to dealing with security, which is the vision here, and we hope to get this for you very soon. It's loading.
Thank you very much.
Cool. Thanks a lot.
Okay. Thank you, Yoav, Asaf, and Nati, for this great presentation. We hope you found it useful. As I mentioned in the beginning, the webinar was recorded, and you will receive the recording. Should you have any additional questions, you can reach out to us at webinars@jfrog.com. Thank you, everyone, and we wish you a wonderful day. Goodbye.